In this video, we're going to take an example task and break it down using the OICE technique. OICE or OICE is O for output, I for input, C for constraints, and E for edge case. We're going to cover the test-driven technique, which is to write a single test, a unit test. So a unit because it's testing a single behavior. So you're not going to be worried about variable declarations or things like that. You're only interested in testing what the code will do, a single functionality, one step at a time. Once we've written our test, we'll write just enough code to pass that test. And once that's passing, we'll refactor to remove any duplication and generally tidy the code. So another part of the test-driven process is, as the tests get more specific, the code gets more generic. So what that means is, when you're first writing the test, it might seem unintuitive that you're actually returning hard-coded values. So there's a reason for that, because you're solving a problem incrementally. So we'll give a demonstration of that. We'll also install Jest globally in order for us to test in any location. So let's install Jest globally using npm install with the -g flag. And let's test it. So we get an error because there isn't a config file. So there's many types of config file, but one of them is the package.json. So let's go ahead and create that one. And let's go ahead and create some scripts to run our test. Excellent. That's working fine. So now let's look at our problem. So the specification is to write a function that takes a string and it returns an object of the words and the number of times the words are used in that string. With OICE, again, the output is an object consisting of the word as a key and a number of the times that the word is used. Input is a string, but it might be empty. So if it's empty, we'll just return an object. So that's output, input, constraints. And in the moment, there won't be any edge cases, but possibly because it could get a bit complicated if you're taking any string and you just want the actual words. So you can use something called a regular expression to split a string or to match any elements of a string. For the moment, we're just concerned with full words, no punctuation, and no numbers. So now Jest is installed. Let's go ahead and start running some tests. So Jest looks for test files in a _tests folder, as well as files that have .spec or .test. But I prefer to use a bit of both, so I like to put my test files in the test folder and suffix them with .spec. So let's write our first test. So looking at the spec, one of the specifications is an empty string will return an empty object. So let's take a look at that. So we'll get an error because dictionary is not defined. So let's import. So we'll have to create that file now. We could call it index, but I prefer to call it dictionary. And because it's not one of the file types that Node.js looks for, we have to specify that our main file is dictionary. We need to export a function and return an object. Excellent. So the next unit of our specification would be it should return the word and the number of times that word is used. So let's start off with 1. So our test fails, so let's write just enough code to pass that test. So what's the simplest thing we could do is to say if there's any words, we know it's going to be a single word at the moment, so let's just add that to the object and add a count. Excellent. So now our tests are getting more and more specific. So let's try and make it more generic. So now we need to split the list of words. So in our README, it says we can use this regular expression to split a string. So let's go ahead and do that. So we can say if word list length is greater than 0, and if it's greater than 1, so we get an error, and that's not as expected. They all fail. So there must be something with word list. So debugging, let's just console.log word list. It's always an empty string. Because match. We need to match the string, not split it. Can I read property length of null? And the first console.log is null. So split, when you match, if it doesn't find a match, it returns null. So let's go and do a conditional. Right, that works. So this is very messy. So let's start cleaning it up. So remember, we want to go from specific to generic. So we're specifically solving the first unit test, we're specifically solving the second unit test. So how do we make this more generic? Well, we've sort of hinted to ourselves that this is a loop. A loop is an if statement repeated. So what we can say is word list for each word and the callback function. So we can get rid of that, and we can get rid of that. And because a word can already exist, we can say yeah, that passes. So we can say we can do a test. We can say if this word exists, then we can increment it by 1. Otherwise, just set it to 1, and that passes. And let's do another test with a different word. Well, that passes as well. So actually, that code is done. It's a little bit messy though, so we could actually reduce a lot. So we could say, let's get rid of result. Actually, let's try a reduce. So as we know, a reduce takes the current and the next value. So the starting value will be an empty object because that's what we're returning. Return. And so instead of result, it would be cur, because that's the current object. Next would actually be the word. So we can say word, And I think that should work. Oh, because we need to return the object.